Back with the final episode of Asynchronous C Sharp with Mr. John Skeet. How are you today, sir?
Hello, not so bad, not so bad.
So we're going to talk about unit testing today, which I think is great because I think
Yes.
it's on everyone's mind. I know that when unit testing asynchronous bits in in JavaScript, it can be quite challenging. So hopefully you're here to tell me this is going to be easy.
Absolutely. Well, not so much easy, but it's feasible. Feasible. Um, so I've kept the existing general example, but normally we've previously used a little GUI, and frankly, as a non-application developer, I find the idea of testing GUI interactions really, really nasty and hard. So I will leave that for people who understand the GUI part more, but I will show you the asynchronous part.
Cool.
So I've kept the authentication service, the stock portfolio service, and the stock price service. So if you remember what happened in the GUI, we were saying we'll authenticate this user, get back their user ID, then find out what stocks they've got, and then fetch those stock prices. Yeah. So now we have a stockbroker class. This is non-GUI, but it still has basically the same kind of thing. So we have a calculate worth async method. And one of the things that we're going to do first is validate the arguments. So I'm not sure whether I've already covered this, but it's well worth going over again. I've said before that when an exception is thrown in an asynchronous method, it doesn't immediately get thrown to the caller. What happens is it ends up in the returned task, so that when you await that task or ask for the result, then the exception is thrown. So that's fine for exceptions that are due to circumstance. But if the caller has basically done something stupid, it would be better to validate that upfront and just throw an exception synchronously. So this is why we've got two methods here: calculate worth async and calculate worth async impl. I'm just going to explain what the methods that we're testing do, and then I'll show the tests. I did genuinely write this in a TDD fashion, but to be honest, with all the switching back and forth, it becomes a bit of a pain. I'll assume you're all familiar with the TDD stuff itself, and let's just focus on how you do the testing for asynchronous stuff. So we split this method up into two. So we've got a non-async. You'll see it's returning task of decimal, but this hasn't got the async modifier method that's public, and that just validates the parameters and then calls calculate worth async impl and just returns the task given by that. So this is a fairly common pattern. If you've done any work using iterator blocks and yield return, you'll see exactly the same kind of thing there. You can avoid doing two different methods with async by having, I could have a func task decimal lambda equals async and then do some stuff. I could have all the code in here, all the code that's in this later method, and then I could just return lambda and just call it. So I could do that, but it's a little bit funky, and I find it's probably clearer just to have a separate method. So once we've got into our async method, it's all the normal kind of stuff. So we're going to authenticate the user, which returns a task of nullable GUID. So we're going to await that task to see whether or not we've been given the right username and password. Then we'll get the list of stocks that the user has. And then we've actually got two implementations here, just if-deft out, as it were. So we've got a serial implementation here, and then a parallel implementation that I can switch between later on. And we should be able to test that both of those work fine.
Okay.
Okay. So what does the test look like? I've actually got, this code is shared between two different projects. I've got two copies of it, just for the sake of demonstrating two different testing frameworks. So I've got one version which is NUnit and one version which is whatever you want to call the built-in one. Most people, I think, call it MS Test. And I want to show you two different approaches in these two. I've got the same set of tests, but it's two different approaches. You can use either approach with either of these test frameworks, but they are fairly different approaches. So I'll show you the MS Test ones first. So we're going to set up have a normal test setup that just creates our stockbroker, and we're using Rhino mocks to create a mock, 3 mock services.
Mm-hmm.
And let's just check a couple of things. First, we expect that if you call the async method with a null user or a null password, it should throw argument null exception. I don't think, and I could be wrong, I don't think that MS-Test has anything like assert.throws, which NUnit does. Normally, I would really prefer to use an assert.throws, and I would probably include my own in a little helper method, because assert.throws makes sure that only the exact expression that you want to throw an exception does. But hey, in this case, we've only got one statement anyway. It's not like anything else is going to throw the exception.
Mm-hmm.
But this test would fail if we went the cheap way. In fact, stuff it. Let's show this. So if I were to, you're not going to believe that it's going to fail otherwise. So if I just get rid of those bits temporarily, so now we've just got one method. In fact, I could even, let's just get rid of that bit. So I'm still doing the validation,
mm-hmm.
but because I'm doing it asynchronously, oh, it's because we need async. Right. Okay, so now we've got a couple of warnings, but we've got working code, or other building code, and now if I run these unit tests, I fully expect to see these 2 tests fail, and indeed they do. So let's fix that to start with. So it gets slightly confusing because I've got these 2 different implementations. So if I go back to the split implementation, rebuild, rerun the tests, and now hopefully, right, everything passes, including the 2 that were failing before. So we know that those 2 very simple tests really are just testing that this bit is executed synchronously.
Okay.
Okay, back to the tests. So nothing async, nothing funky yet. Right, so now we get on to our first interesting bit. So we're going to pretend that we've got an authentication failure. So we're passing in the right username and password. A username, but the wrong password.
Mm.
And whereas previously we wanted to test that bad arguments, things that could be known to be bad by the caller, are thrown, an exception is thrown immediately. This time we want to prove that we don't get the we don't get the exception straight away, only when we await the result of calculate worth async do we have a problem. So just to really make this clearer, if we fetch the task, okay, if this call threw an exception, then this test would fail. But instead, we're going to await the result of an assert throws. So this is kind of funky already. We've got await in a test. Yeah. And you'll see we've got async in a test. And this is one of the features of MS-Test that now XUnit and NUnit both support as well, this idea of writing async tests.
Oh, that's great.
Well, it's great, but there's one big caveat. I could write this, and that would still be valid code, but you shouldn't do it. You absolutely shouldn't do it.
Right.
Because now, don't forget that the fact that it's async, the compiler, anything trying to use this can't tell that it's async just by the async modifier, because that's not part of the compiled code. Right. Yeah, there are some attributes around it, but it's not part of the signature. So the async support in all of these things lets you return a task, and it will do the awaiting on the task that you return. So, big tip number 1 is return a task from your async tests. I think NUnit actually kind of manages to work things out, but it's going to give you a better experience if you do this properly.
Right, and that makes perfect sense because NUnit's got to evaluate the result of this, and if you don't tell it it's asynchronous, then it's not going to work. Okay.
So there's some magic in the context that lets it say, well, I've started more things than I've finished, but it's best if it doesn't need to rely on that. Okay, so let's look at what our test actually does now. So we're going to make a stub call, or rather expect a call to our authentication service. So when this call is made to our mock, then we're going to return this delayed. I'll explain that in a sec. We're going to return a value of null, and we're going to delay that by 100 milliseconds. So if we look at delayed, it's really, really simple. This is just in the test code as well. All it returns, it doesn't await, so it will delay that many milliseconds and then return the result. Okay, so at the point where we return back to, sorry, scrolling back up to the test, at the point where we've created the task, the authentication task won't have completed yet. So I could add an assertion here. It would be a little bit flaky because it's possible that things would be delayed by 100 milliseconds before this task returned. But I could do assert.r equal task dot is completed. So I think that would return true if it had completed in any way, shape, or form. So this test should still pass. Which proves that the delay is working. If we delay it by 0, it's possible that it will now fail. I don't know exactly how the asynchrony works here, so whether we now probably do have a race condition. Oh yeah, it's now failed. So because we've said that the authentication service is going to return a task that's immediately completed with a result of null, the test now fails. So back to properly asynchronous. So we then, having set up our mock, we call our calculate worth async method, it returns a task, and then we call this assert throws. So this is just something that I've hacked together in my code. So what we do, we just await it. So we're given a task and we expect it to fail with a certain kind of exception. If it doesn't fail, that means that the test has failed. If you see what I mean. We're expecting an exception to be thrown. So if the await completes without an exception, then our test is broken.
Okay.
Or rather, our production code is broken. So if we manage to catch the specific kind of exception that that we expect to be thrown, then that's absolutely fine. If a different kind of exception is thrown, then it's still a fail. Make sense?
Yes.
This is just like the normal assert.throws.
Right.
I expect that this call will throw a particular kind of exception.
Right.
The only thing is it's asynchronous. So it returns a task because we're awaiting something. So we're going to say, here's a task which will fail sometime in the future in a particular way. Please return me a task that will throw an exception if it doesn't fail in the way that I expected it to.
Right. That makes sense. Yep, makes sense.
Okay. And then we need to await that assert throws result. So we await the task that is going to go bang if our original call didn't go bang. Okay. Fortunately, that's the kind of trickiest probably to explain until I get onto the end unit tests. So then I have a bunch of calls saying, if we have an empty portfolio, so we stub out the auth service to say, yes, we return some random GUID. And then if we're asked for the stock portfolio for that GUID, we're going to return, again delayed, a new empty list. And if that happens, then we shouldn't get any calls to our other service, and we'll have a net worth of 0. Then I've got another example where we've got a portfolio with one stock holding. At this point, it's all kind of what you'd expect. The fact that we've got awaits every so often sort of almost doesn't really feature too much.
Mm-hmm.
We've got every time that you would normally do a return a value, we're returning a delayed value, but that's relatively straightforward. And then when we've got the task, we await it in order to find out the net value, and this time we're simply doing assert.r equal, so we could easily pull this out. So this is hopefully sinking in with listeners now that anytime we've got an await expression, it's fine to do decimal total value equals that. And if we wanted to, we could even do var value task equals, so we can pull this bit of the await expression out and then await that task specifically.
One thing that's coming to mind as I'm watching you do this, that I've done with JavaScript is to not test necessarily the result of an asynchronous thing. So in JavaScript, you send in spies, right? And you can use those spies and say, yes, this callback was fired or this callback was fired. But rather than testing the values that come back from that, you just test individually those methods that do the thing, and you do it synchronously in the tests. I'm wondering, do you know what I'm saying? So I'm wondering, do you see value in that approach at all with this?
You would certainly unit test each individual bit, but Stockbroker is a sort of integration point. So it's got these three services, and don't forget, we're not testing the services here. We're testing how they integrate together.
Right.
And our only method call is going to call authentication service and then portfolio service and then price service.
Right.
So we can't test each of those individual calls without stubbing out the other ones.
That's true. Okay.
But we can test them even though they're asynchronous. Now, currently, because I've got a delay of 100 milliseconds or 200 milliseconds, it takes a certain amount of time, but at least I'm pretty sure this isn't going to end up with race conditions. So at the moment, although we are calling delayed, so the fact that we've delayed by 300 milliseconds and then called something, we've waited for 100 milliseconds and then waited for another 200 milliseconds. Actually, by the time we've got the portfolio, the price is ready to go. So it's a little bit tricky in that sense. So we might want to up that a bit. And the fact that we're using async means it's easier to get the calling code right, the production code right, so that these race conditions aren't really a problem. But here we are still using genuine threads and real time as opposed to fake time. And you'll see what I mean by fake time in a minute. So if we get multiple requests, we've got a couple more tests. So we're going to look for foo and look for bar, and this one comes back a bit later than, let's make that 300 and 200 to give a bit more time. So the request for foo comes back before the request for bar comes back before the request for foo, but we should still get the right values. We're not going to mix up the price for foo with the quantity for bar. If we did, our tests would fail. So it doesn't matter exactly how we check that. But it is slightly tricky. I mentioned before the serial and parallel part. It would be relatively tricky in this way of doing things to know whether we were doing something in series or parallel and test that. We could time things. We could see how long it actually takes in physical time. But then at that point, in order to make the test robust, you probably do want to make the test wait for a few hundred milliseconds, just to get rid of jitters in timing. And when you've got several tests all taking half a second or so, that's going to really mount up. So Nodatime, for example, has 7,000 or 8,000 tests at this point. You really don't want those taking half a second each.
No.
And that's a relatively small, that's a one-man project, basically. Obviously, hopefully listeners are used to big projects with many tens of thousands of tests. They wouldn't all be for async stuff, but we want to keep things fast. So we'll keep that in the back of our minds at the moment. So we've got another test where we've got foo and bar again, and we can't get a value for bar, but we still get a result just from foo. So that's fine. And that's all we're testing. And it's all working and easy.
Woohoo!
Yeah, so I've sort of almost not made a big deal of this, but without the async part, this would have been a bit of a pain.
Yep.
So you could have blocked instead of awaiting the results, but I honestly don't know the asynchronous context in which tests, or the synchronization context in which most of this stuff runs. So if it's using a thread pool context, then it would probably be okay. But imagine you had a thread pool with only one thread in it, and it would be a bit of a mess. So the fact that it's async really helps, and you can obviously, I think all of these tests are actually only awaiting one thing, but you can have multiple expressions in the same test.